You guys have a respite from that. You do have scientific notation on there though. So I highly suggest that in the moments before the quiz, just glance at these two warm-ups, 7 and 8, just to remind yourself how to do those. Okay. There's not laws of exponents other than scientific notation either. Okay, now we're going to do domain and range for this list of points. So -7 is the lowest. I'm only going to write it once. -6 is next. I'm only going to write it once. And then 5. Also, I can clearly tell this one is not a function immediately. Okay, and then the range. The lowest is -7. Thank you, honey. And then 0, yep. Then 1. And then 5. Okay, when we look to see whether or not something's a function, we only look at the x's. And we're looking for repeats. It's definitely repeats, so not a function. -7 and -6 have two different outputs. Okay, now we're going to talk about the phone holder. Eli, number 7, please. Jack, number 8, please. 9 and 10 are okay. Get up and put phones in the phone holder. When I say this, I'm not joking around. I already know. Quincy, 14. Landon, do you have one with you? You're number 18.
I'm 17.
You are 17.
Yeah.
18, 19's good, 20, 21, 22. Okay, Dylan,
Right there.
which number?
21.
You're supposed to be in 23. 21 tomorrow. No, 20 tomorrow.
Next weekend.
Yeah. The stars. Michael, 25. I love you all, but I'm having trouble believing that you're all leaving them at home. But I'll just email your parents and ask. Okay. Move on. If you guys could find the page in your packet that has number 68. Number 68. Okay, and then you need to find the little cards that I left in your table and the envelope. I left every table a little envelope with 6 cards. The first thing I need you to do is to look through the cards with your group. Just take 30 seconds and decide which ones you can actually grab. You're not going to grab them yet. You can start if you want to, but some of them are based off of other ones. So what I want you to do is just read them as a group, figure out which ones you can actually do. I think there's 2 of them that you can do. So find those 2. To have enough information. 56 in there, which 2 have enough information to grab? Anyone have any guesses of which of one of them that will work?
We're not graphing.
Elizabeth, yeah, Elizabeth will work. Okay, so Elizabeth works for now. They all work, but which one can we do at the start? And there's another one too that you have enough information for. Leslie, did you read to Leslie?
Yeah.
Okay, so we're gonna start with Elizabeth and Leslie. And just pick colors that you want them to be. I'm gonna start with my blue, as I always do. I'm gonna start with my blue for Elizabeth. Okay. The other ones don't have enough information yet, but they will. Okay, so Elizabeth is 11 meters into the race after 4 seconds. So you're gonna find 11 meters. It should be over there. It's a hand one for the color pencils. Okay, so Elizabeth is 11 meters into the race after 4 seconds. So I went 11 meters, 4 seconds, but is only 13 meters in after 12 seconds. So 13 meters in after 12 seconds. Let me make sure I did that right. Okay. Okay. For Elizabeth, we kind of have to take a minute to figure out the slope. So I'm going to take whatever colored pencil I'm going to use. And I'm going to make a slope triangle underneath. Do you guys have any questions about how I made my slope triangle? Does it make sense? Okay, is anybody willing to venture a guess what her equation is? Yes, no. I got 10. Did you guys get 10? Did I graph it wrong? Okay, just checking. Okay, so I like what you said too. You already reduced the 2/8 to 1/4. Okay, everybody, Elizabeth, as soon as you're done with this, Elizabeth is done and you can set Elizabeth off to the side. Elizabeth's card can go back in the envelope. She's done. Also, what do we notice about her in the race? She's what did it say on the card? Yeah, she's got a flat tire. So yeah, slow. Okay, now we're gonna go to Leslie. Leslie's got a special circumstance. There's something different about Leslie than all of the rest of them. Anybody notice? Use your mathematical powers of analyses to tell me what's weird about Leslie's card. Yes, Landon.
She started late.
Yeah, she started late. She did not get a head start. She got the opposite of a head start. Okay, so what you're going to do is you're going to say, okay, she starts 2 seconds after the start. So you're going to go over to 2 seconds for her first stop. That is her 2-second delay. And then it says she rides 2 meters per second, which is pretty fast. So 2 meters per 1 second, 2 meters per 1 second. Okay, now we have to do something a little bit special for this one. We have to take our line, we have to trace it back to the y-intercept so we can get B. So you're gonna have to make your line go all the way up, but also make sure to get this bit here. Also to check my work, did everybody get the final dot up here, 4 boxes over? Okay, just checking to make sure I did it right with my pen. Okay, so I'm going to take, yes, honey. What do you want to, do you want to say what her start is? What her y-intercept is? I heard somebody say it. Mike? -4. Okay, and you can find this because if you go down to back one, you're going to go down to back one again. And so that spot will be -4 because you're at 0. Then you'll be at -2. And then you'll be at -4. Okay, Mike, can you tell me what her equation is then? Beautiful. All right, class, it's 24 minutes in and you've already blown through the 2 people who always raise their hands. So the rest of you are going to have to get brave because we're only done 2 cards. What? So she started 2 meters after. So I backtracked down 2/1. So that would be at -2. And I backtracked again down 2/1. And then it crossed the y-axis at -4. And Miss Rice was in here this morning. I don't know if you saw her leave, if you guys are standing outside. And we were just talking about how we kind of wish this graph went into the negatives over here. It would make that a little bit easier. But we're okay. We got it. Okay. Now, you guys can put Leslie back in the envelope. Okay, next question. Can we do rider A? Do we have enough information to do rider A? No, why not? What does rider A need? B. Okay, so let's go to B. Do we have enough information for rider B? You get the same head start as Elizabeth and ride 1 meter every 2 seconds. That'll work. Okay, so where should I put my first dot? How much of a head start did Elizabeth get? 10. So same head start as Elizabeth. And then it says 1 meter every 2 seconds. 1 meter every 2. 1 meter every 2. Does anybody feel brave enough other than the 2 people who already answered? Yes, Lenore, go ahead. The equation. Beautiful. Okay, now you have definitely cleared the 3 people who raised their hand most in the class. Okay, can we do A now? Or do we have enough information to do A? Mike, is your hand up or are you stretching? Yes. What do you want to say? What?
I don't know if we have enough to, I don't think we have enough information yet.
I think we do. Well, okay, we have to interpret it correctly. A rider tries to go 3 meters every 2 seconds and pass rider B 10 seconds after the race begins. Okay, so what I think we should do, hold on, I got to get my purple. I think we should go 10 seconds after the race begins. And when you pass someone, that means that you start at their dot. Okay, so what that means is I'm going to go 10 seconds in. So go over 10 seconds in on the x-axis. And then it says you pass rider B. So find where rider B is. That's going to be our first dot. And then it says you ride your tricycle 3 meters every 2 seconds. 3 meters every 2 seconds from there. That means we're going to have to forward track and backtrack. So 3 meters every 2 seconds. 3 meters every 2 seconds. Okay, so I got as far up as I could go. Now I need to go backwards. 3 meters every 2 seconds. That's a popular dot. Okay, so what kind of head start did this person get? None. Poor person. Person A? All right, I need somebody else brave to tell me the equation. Nope, you already answered one. Somebody else brave. Sam?
Y equals 3/2 x.
Beautiful. I like how you left it x. You could also say 3/2x plus 0, and that's totally fine too. All right, we have dos mas, except we almost ignored an extremely importante fact back on rider A. There was one more thing. Yes, Landon. Okay, so I gotta go out 25 and make my finish line. Okay. In the envelope, you can have Elizabeth, Leslie, A, and B. We only need to do C and D left for this graph. This graph's already getting crazy. Gonna have to go some kind of orange, I think, next. Okay, let's go to C. You ride half as fast as Leslie, but get a 4-meter head start. Okay, so 4-meter head start, that's easy. Over here on the 4 meters. And then half as fast as Leslie. How fast did Leslie go? 2 meters per second. What's half of 2? 1 meter per second. So 1 meter per second. Oh, it's gonna be a lot of dots. 4-meter head start. Everyone's going through that same point. If I'm doing it right. Yes. Okay, hold on. Does anyone want to give the equation? We have someone who's just dying to give the equation. Titus wants to give the equation.
1x
Plus 4. Okay, now this is beautiful and perfect and 100% full credit right there. You could also just say x plus 4. But 1x is always good. Don't ever think that that's like a problem. Yeah. Okay. Last one. Gotta find a final color here. Light blue. Rider D. You get a 1 meter head start and catch up to Elizabeth in 4 seconds. Okay. Rider D, you get a 1 meter head start and catch up to Elizabeth in 4 seconds. Okay, do you guys all see that that's this dot right here? So the Elizabeth line, 4 seconds. Do you see it? Okay. It's going to be kind of hard to draw. So head start at 1. Oh man. Rider D. What do you notice about Rider D? Anything? Nothing? They're really fast and I think they won, right? Yeah. Okay. Now, we need to figure out how fast. So I'm gonna come back over here and make a slope triangle on this one. I have a quick question, just check for understanding question. Did I have to make my slope triangle this big? No. Are you all wondering why I did?
No.
I did just because I used the 2 points they gave me, but I could have used this point. All right, somebody completely new. Tell me right or D. Yes, me. Almost 10/4. Okay, I'm gonna write it two ways. What? Okay, hold on. Oh, yeah, it's fine. I'm gonna write it two ways. First, I'm gonna write it 10/4x plus 1. Okay, exactly the way Peyton had it. Then I'm gonna reduce this y equals 5/2x plus 1. And I noticed the 10/4 both even numbers, so I can reduce it. So writer D, I'm going to reduce the 10/4 to 5/2. Mrs. Talbot, do you realize if you had just made a smaller triangle, you would have gotten the 5/2 immediately? Yeah, yeah. But I wanted to use the points that they gave me because I'm thinking that that's what a lot of you guys would do. So, okay. You guys are done with the cards and the resource page, but don't put it away. Just set it to the side. Because we have to answer questions about it in number 69. Okay, let's go through the questions. So we're on number 69. We're going to answer all of these questions about the graph we made in number 68. So here we go. By the way, here's our agenda for today. We're doing 68 to 70, which is the finals of the big race. We just did the race part, 68. 69 is asking questions about it. And then number 70 is talking about the word solution. We need to talk about what that means. Then we're going to do notes on X and Y intercepts. It's just one problem. It's not long. And then we're going to do the quiz. This is the homework, and it's in your packet. There are 3 worksheets. And you're like, Mrs. Talbot, 3 worksheets, how could you? Okay, but the first 2 are literally just matching. I think if you take longer than 15 minutes to do this homework, there's something wrong. So the first page, the graphing stories and situations, you just match the story to the situation. The describe the velocity graphs, you match them and you just write what's happening. And then the Sarah's graph is one where you describe it. Do you remember the one we were talking about walking away from home or toward home? It was in your packet, number 55. That's right. And then the joke is, I miss the days when the homework was just coloring. You don't? You're not a coloring person? What about slope triangles? We kind of have some coloring. Okay, anyway, back to the book. Later that day, use the results from the big race finals to answer the following questions. You may answer the questions in any order, but be sure to justify each response. A, who won the finals of the big race? Who came in last place? Who won and who came in last place? Okay, yep. D won because they crossed the finish line first. Who crossed last? So last it's not even on there. Elizabeth, right. Okay. So D won. Elizabeth came in last. B, which riders other than the winner were in first place for a while? For approximately how long was this rider or riders in first place? Okay, so let's take a look. Which rider was in first place before rider D took over? Rider B, right? Rider B is on the top here, which means that they were the furthest in because of this gigantic head start. Okay, where about did rider D pass then? Yeah, about 4.5 seconds in. Okay. C, how many seconds did it take to win the race? About 9.5-ish, you think? Okay. For those of you out there that don't love that these are not perfect whole number answers, the book is trying to get you used to that so that you're not scared or worried when that happens. Because in real life, it wouldn't be a nice whole number answer for sure. Now, if you are though, I totally get it because I like it when they come out evenly also. D. How fast was rider D traveling? How fast was Elizabeth traveling? Answer using unit rates. Okay, so this is getting us to practice unit rate. Rider D was going 5 meters every 2 seconds. Do you guys see where I got that from? 5 meters every 2 seconds. Okay, how do I make that into a unit rate? Do you guys remember what unit rate is? Let me help you. Unit rate is a slope with a denominator of what? How do I get a denominator of 1 here? Divide by 2. Beautiful. Okay, so I'm going to say 5 divided by 2. It's 2.5. Yep. Meters per second. Okay, I want you guys to try Elizabeth real quick. Write the unit rate for Elizabeth. Give it a go in your group. Did anybody get it? I heard Titus get it. Beautiful. Okay, 2 more questions and we're moving on from this problem. At one point in the race, 4 different participants were the same distance from the starting line. Who are they and when did this happen? Hey, didn't I say something about that? 4 people were in the same spot. Where did that happen? Mike? Yeah, 812 right here. 4 different lines are going through 812. And those people are, let's see, Elizabeth, who else? Leslie, what? Yep, Elizabeth, Leslie, and what are the other 2? A and C. Okay, last question for this. What would the graph look like if one of the riders fell off their tricycle? What would the graph look like if the riders fell off the tricycle? Yes. So it would probably look something like this. Like they'd be going and then they fell off and they would stay in that exact same spot. They might roll. There might be rolling. It would probably be hilarious, embarrassing rolling if it was me that fell off. The more embarrassing, the better. All right, you guys. Number 70 to set up. Okay, so first question I have is number 70. Take a look at that equation. Who is that? Which writer? Leslie. Okay, so what we're going to talk about is Leslie's line and what does it mean to be a solution to a line? Okay, on all of these points, do you see all the points I graphed, the little dots? Those are all solutions to a line. And all of the points in between, if these were graphed perfectly, would also be solutions. There's infinite solutions on a line, which means infinite dots. Okay, so when we want to find out if something is a solution, we can do it in two ways. We can look at the line and see if the point's on the line, or we can do it algebraically with substitution. So I'm going to take a different color real quick. I'm going to put X and Y here. So a solution means, is it on the line? I'm going to check in two ways. So
Never mind. Oh, never mind.
8 is Y, so I'm going to put 8 in the Y spot. It's just that the problem is the HDMI in this doesn't like the coaxial cable in that. They fight each other, and once in a while it goes dark. And it comes back in a second. It happens all day long, every day. Drives me nuts. Anyway, okay, so I took the 8 and I'm putting it in the Y spot, and I'm going to put the 6 in the X spot. So I put the 6 there, the 8 there, and if these two sides are equal, then that means it's a solution. 8 equals 12 minus 4. 8 equals 8. Okay, I'm going to show that now on a graphic way by graphing this. So y equals 2x minus 4 means that I start down 4. So this is negative 4. And then my slope is 2. So up 2 over 1. From the 2 right here. So the slope is 2. So that means it's going up 2 for every one it goes over. Okay, now the question is 6, 8 on the line? 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6, 7, 8. Would 6, 8 be on the line if I made my line go further? Yes. So this is the way to check with algebra. And this is the way to check on the graph. See if it's on the line. Okay, now we're gonna do 8, 10. Let's check with algebra because 8, 10 is way over here. So this is X, this is Y. 10 equals 2 times 8 minus 4. 10 equals 16 minus 4. No. All right, we have one more problem. I think it's one problem. The X and Y intercepts problem, and then quiz time. What? Yep, this is the last thing before our quiz. So I want you, before we start, I want you to notice something about this equation. Does it look like our other ones? No, this is called standard form. Standard form, we haven't probably ever seen it yet. We've been using slope intercept form. Slope intercept form means that you see the slope and you see the intercept. This is standard form. You can't really tell what the slope and intercept are. I have to tell you, I usually just wing that. But, okay, standard form's only good for one thing. It's kind of a pain in the butt, nobody loves it, but it has one good thing. It's very easy to find the X and Y intercepts. That's why I chose standard form for this particular example. Okay. So, X-intercept is where y equals 0. And the y-intercept is where x equals 0. I know it feels weird because like x-intercept and then it's y is 0, y-intercept and then where x is 0. So what you're going to do is you're going to do this two different ways. Okay. And then I'm going to show you it's a really easy way to do it that one of the middle school teachers taught me, because middle school teachers can be brilliant with stuff like this. We're going to do two little problems. We're going to do y is 0 and x is 0. So I'm going to find the x-intercept where y is 0, and I'm going to find the y-intercept where x is 0. So what I mean by that is I'm going to say 3x plus 6 times 0 equals 24. So I just put a 0 in the y spot. 3x equals 24. X equals 8. That's the coordinate 8, 0. Because it goes x, then y. Okay, now let me show you this super cool thing that's middle school teacher taught me. I can't remember which one. They call it the cover-up method. When you want to find the x-intercept, you just cover up the y, and you get 3x equals 24. You see it? So easy. Okay. So now graph the point 1, 2, 3, 4, 5, 6, 7, 8, 0. So that's this one. Okay, now we're going to do the opposite. So 3 times 0 plus 6y equals 24. 6y equals 24. Divide by 6. Y equals 4. What coordinate would this be? 0, 4. Okay. What?
On the Y line?
On the y line. Beautiful. Okay, and you could get that also by just covering this part up. So cover up the x part, and you can tell that y is 4. And then you can use your ruler and make your line because you have 2 points. That is the only strength of standard form. Okay, now, much more difficult question. After you graph the x and y intercept and get the line, could you now tell me what the slope intercept form is just from looking at the line? Okay, so what is the slope?
4/8.
A lot of those things, it's negative half. Negative half. Can you guys tell it's negative half? You have to remember about the negative. Okay, and then what is the start? 4. So it'd be y equals negative 1/2 x plus 4. And you can get that from the picture after you get the x and y intercepts if you needed to. All right, everybody. Okay, this is what you need for your quiz. You need a pencil, a straight edge, and a calculator. Pencil, straight edge, calculator. Yeah, backpacks along the wall, please.